here we have section 2.4, exercise 94. In this exercise, we're supposed to evaluate the second derivative at the given point. So we have g of t is tangent of 2t, and we want to evaluate the second derivative at pi over 6. Right? I think that's what it says. Evaluate the second derivative of the function, and then we want to verify our result. So we'll do that as well. Okay, so g prime of t, well, we need to take the derivative of the tangent, right, because we have the tangent of something. Well, the derivative of the tangent is secant squared of that something, and then times the derivative of 2t with respect to t. So there's our 2t. Well, that's just 2, so we get 2 secant squared, whoops, try that again, 2 secant squared of 2t. And then we need the, this starts to get more complicated, you see, because now as I look at this, what I see is that I have 2 times something squared, and that something is the secant function of 2t. Sorry. Gets wild there. And so, let me put an equals there. So is, you know, when I look at this to take the derivative, the 2, of course, just comes along, but I need to take the derivative of the squaring function. I need to take the derivative then of the secant function, and I need to take the derivative of the 2t. So squaring function, that's pretty straightforward. 2 to the 1. The secant function, gosh, good question. I think that's something like secant tangent. Well, I'm going to go over here to another page because I don't remember. You say, well, gee, why don't you remember? Well, because secant, that's just 1 over the cosine, right? So I have 1 over the cosine is the secant function, so we'll put secant here, t equals 1 over the cosine. Or I could say that that's cosine of t to the negative 1, not to be confused with inverse cosine where you put the negative 1 right there. So it's a funny math thing. So this is 1 over the cosine. So if I take the derivative of this, all right, well, in that case, I have that negative 1, and then I have the cosine of t. Well, the negative 1, of course, bring the negative 1, and then to the negative 2, like that. And the cosine is going to be minus sine of t, like that. And so when I take that derivative of secant t with respect to t, I get that minus 1 times cosine of t to the minus 2, and then all times minus sine of t. And so what we have here, well, we take care of the negatives, that makes a positive, and so we have sine of t over cosine of t, oops, squared. And so if I write that as 1 over cosine of t times sine of t cosine over cosine of t, then that is the secant function, and that is the tangent function. And so this is secant t tangent t. Okay, back to here. So I know that that's secant of something tangent of something. and then I know I just get 2 from the 2t. So I'm ready for that second derivative. G double prime of t is equal to 2 times the secant of 2t to the 1, and then times the secant of 2t times the tangent of 2t, and then finally times the 2. And so this is equal to 4 secant squared 2t and times tangent of 2t. And now we were supposed to evaluate that again at pi over 6. So g double prime of pi over 6 is 4 times secant squared of, well, 2 times pi over 6 is pi over 3, and times tangent of pi over 3. Well, so for me, I have to draw my reference triangle, and you know, this is a 1, I usually draw it this way, 1, 2, square root of 3 triangle, and the pi over 3 angle's actually up here when I draw it this way. This is the pi over 6 angle down here. So tangent of pi over 3 is the square root of 3 over 1. So this is equal to 4. And this one is square root of 3 over 1 from the tangent. Now secant is 1 over the cosine. So the cosine was the, cosine would be the 1 over 2 for this angle. Opposite over, oh sorry, opposite. The adjacent over the hypotenuse. And but secant is 1 over that, so it's actually the hypotenuse over the adjacent. So that's 2. And so that's 2 squared. So we get 16 times the square root of 3. Okay, so that's my answer, and I'm sticking to it till I decide I was wrong. Okay, so let's check that in something like Desmos, and we can do that pretty easily. So let's go back here to our original function, tangent of 2t, and we're interested at pi over 6. So we go to Desmos. Now, Desmos, you're best off using x as your variable, and so we're going, and we want to say f of x or something, g of x or whatever. It was a g, I guess, so we'll go with g. G of x is equal to tangent of 2x. Again, it is best if you use x, not t. We'll get confused that way. So then, all we have to do is go with g double prime. And so here's g. And, whoops, wrong thing here. Okay, double prime. There's 2 primes. Now we go here, g double prime of pi over 6. So pi divided by 6. And go here and we'll close that off. So 55.425, is that what we got? Well, good question. We had, what, 16 times the, no, is that right? What, I gotta go back here. Look at what we had. 16 times the square root of 3? I don't think that's the same answer. So that's interesting. Let's try this out. So 16 times, because 16 times 3 is 48. So like I say, it doesn't seem like it's the same answer. Square root of 3, 27.7. We got half. Okay, but that's interesting. Okay, so we come back here and we say, okay, where did Dillery go wrong? And it's okay to make mistakes. You just try to find them. And let's see, so we need our first derivative. Okay, so our first derivative, it looks like our first derivative, I got 2 times secant squared of 2t. So one thing we could check is, what's that at pi over 6? Did I get that right? Okay, so you know, the question is, did I get this right up here, and then we look for the error later, you know? So I mean, we make mistakes, and so part of it is trying to figure out where. Okay, so I go back here and I do an f of x. F of x is equal to, and I believe I said secant of 2x, 2x. Okay, so we have the secant of 2x. Let me go back here. I think it was 2 secant squared. Yeah, 2 secant squared of 2t there. But so let's take a look here. So I need a 2 in front of that. And then I need a squared. Well, I think the only way I can do it myself is, backspace over that and come over here and put it there. And then do the square. So I have that, and then I can look at f of pi over 6. And according to that, oops, what did I do? Nope, I'm having troubles here. Okay, there we go. We get 8. Is that what I think we should have gotten here? And again, we had this 2 secant 2x or 2t. T was pi over 6, so this was secant of pi over 3. We decided down here that secant of pi over 3 was 2. And so we have 2 times 2 squared, which is indeed 8. So that's looking good. Okay, so it looks like we did okay there. Then here, I have, oh, well, no, okay. So I have my 2 here, and then, there we go, right there, that 2. I didn't bring it down, right? I said, oh yeah, that goes along for the ride, but you see this 2 came from there, and so, yay, I found it. Okay, so this should have been 2 times all that, and so we should have had an 8. That should have been an 8. This should have been an 8, and so this should have been 32 times the square root of 3. So, I lost a 2 in there. Happens. We found it, and by using technology and so forth, I was able to check my answer. So it should have been 32 times the square root of 3. And if I go back here, we should get answers to match up. All right, if I backspace on that and get 32, and there we have a matchup. So, I sort of am sorry I made a mistake, but actually I think it's okay, because you need to see that I can make mistakes as well. But what do I do when I make mistakes? How do I realize I did make a mistake? Sometimes it's, in class and people point it out to me. But other times, it's just through checking my work in various ways. And here we checked it, and I was wrong. And so I went back and fixed it. Now, of course, what I could have done was restarted this whole video and done it right the first time through. But I think that sends a very poor message as far as doing mathematics. Even though with calculations, we certainly want to get them right. When all's said and done, anytime you're doing mathematics, you can make mistakes, and you can get stumped, and all of those things. And so, what do you do about it? Well, you just keep going. Math is full of making errors at times, and I think we do a very poor job as math teachers of pointing that out. And so here we, I made a mistake. I didn't try to make a mistake. Oh, I hear beeps on my door. So I think that's good for this problem.